Welcome to the class discussion for Unit 1, Activity 5. The following data was collected by Rex Boggs of Glenmore State High School in Rockhampton, Queensland, Australia. Rex was investigating the relationship between time and the weight of a bar of soap. In this problem, you will use linear regression to model the weight of Rex's bar of soap in terms of time. So here are the number of days that have passed, and here is the weight of soap. Let's look at Part A. Let's use technology to graph the data. Now, if you've looked at the fold notes on Canvas, then you'll see that there's appendices for how to do this with TI calculators. I'm going to show you here how to graph it on a TI calculator. So begin by going to the Stat menu, which I'm mousing over now, and clicking on that. And then we're going to hit Edit and go Enter. And under List 1, let's enter in all the days you see here, and that will be here under List 1. So we're going to type 0, 1, 4, and so on. Go ahead and pause the video and finish completing this list. Now that that is done, over on List 2, you're going to want to enter the soap weights. So please pause your video and enter the soap weights here under List 2. All right, your calculator, if you're using a TI calculator, should look just like mine here. And now let's go to this y equals, but I don't want the y equals. I want the stat plot that's in blue. So I'm going to click on this second button and then the y equals, and that'll take me to stat plot. It is off right now. I want to turn it on. So I'm going to click Enter and then Enter again for on, and type. I'm going to leave these dots. Then my x-axis is going to be the points on L1, which is the days. So horizontally we'll have days that have passed, and vertically, as you see me mousing up and down, vertically the y-axis will be made up of the weight of the soap. So now we can graph. And now I don't really see anything, so let's fix our window. So if you look, our days go from 0 to 12, so our x-axis should start at 0 and go to maybe like 15 at most. So let's go to the window here and fix that. So I'm going to go from 0. Actually, I'm going to go a little bit before 0 just so I can see what's happening. I'll start at -2. I'll go to 15. And I'll leave my scale at 1. Now for the y minimum, our smallest y value is 50, but I don't really want to start and not be able to see the x-axis, so I'm going to start at 0. And then I want to go up to at least 124, so I'm going to type in 150 as my max y scale. And then I don't want 150 little dots. So let me show you what I mean. This line is really thick, and I can't really tell what number any of these are vertically reaching, so I can't tell the height here because there's so many dots. So I'm going to go back to window and change my scale. I don't want it at 1. I'm going to say make it 25. So now when I look at my graph, I know this point here is 50 and this value here is right about at the 50 mark. So here's 50, here's 100, here's 125, and if you notice, my first data point of 124 should be right below that. At 0, I should be at 124, and that looks correct on my screen. Next, let's answer Part B. The graph should illustrate that the data is not linear. How can we also use the data in the table to show the data is not linear? If the data is linear, we should have a consistent rate of change between consecutive x values. So from 0 to 1, these are consecutive. From 4 to 5, or any of these consecutive ones, from 4 to 5, 5 to 6, 7 to 8, and so on, and also 11 to 12. So how about we take a look at the slope between 4 and 5, and 6 and 7. Or better yet, 4 and 5, and 5 and 6. So the slope between points 4, 103, and 596. Let's do that one first. So this slope is 103 minus 96 divided by 4 minus 5. You should end up with 7 divided by -1 or -7. Now let's take a look at a different slope. Let's take a look at the slope between 5 and 6. So that's the slope between 5, 96 is an ordered pair, and 6, 90 is an ordered pair. So my slope here is 96 minus 90 divided by 5 minus 6. So you should end up with 6 divided by -1 or -6. So since the slope is not constant, that is the slope here between these two values is different between the slope here between these values, we know this is not linear. And I'm calling this x and this y, especially since I'm specifying x in my answer. Now let's take a look at our graph again. If you notice, the graph looks like it is roughly linear. I could draw a line across this way and get pretty close to having a straight line that maybe would touch most of the points but not all of the points. Next, let's find the regression equation. Since we already have everything entered into our calculator, that is, if you go to edit, your data on your calculator should still match the data on your table. We can use our graphing calculator to find our regression equation. So we want to go to the stat menu and scroll here to the right to calc, and then go down to number 4, linreg, and my x values again are under L1, and this is L1, and my y values are under L2, and then I want to store my regression equation. So I'm here, my cursor is blinking over store regression equation, and so go ahead and click vars, and let's go over here to y vars by scrolling to the right, and then under 1 we want function, and go ahead and check y1, enter. And that means it'll store your equation under y equals, and you'll see really soon that's super nice because then we can have a scatter plot with a line over it. Now let's go down to calculate, enter. And so I'm going to write a few things down. So on your TI, you have y equals ax plus b. A is equal to negative 5.877944325. B is equal to 125.5310493. So this is what we have here from our graphing calculator. And our slope is here into 4 decimal places. That would be 1, 2, 3, 4. And this one, the y-intercept, would be 4 decimal places here. So our slope is negative 5.8779. That is multiplied by x, and then we're going to add 125.5310. And I'm going to go ahead and leave the 0 here just to really emphasize that this is to 4 decimal places. Next, we're going to graph the linear regression equation we found in Part D on top of the data. And this will confirm that the data is roughly linear. And of course, since you stored your y variable under the regression, it's here. So there's your equation, and it's the entire thing. It's not rounded to 4 decimal places as we did. If you notice, I'm just scrolling to the right, and you can see the entire equation. So now let's go graph. And look at this. It's sketched a line over our points, and this confirms that the data is roughly linear. Next, what is the slope of the regression line, and what does this slope tell us about the slope? The slope is negative 5.88. And actually, let's continue to 4 decimal places. So the slope is 5.8779. This tells us that for every individual change in x in this direction, the y values change by 5.8779. That is, they go down since it's negative. Let's write that up as a sentence. For every one change in x, the number of days. The y values that represent the weight of the soap in grams decrease by 5.8779. So the weight of the soap is decreasing as time elapses. Next, according to Rex's data, how much should the soap weigh at first? And if we look here at day 0, the soap weighed 124 grams. According to the linear regression equation, how much should the soap weigh at first? According to the linear regression equation, it weighed 125.5310 grams. How much do our answers vary in part in G and H? So if you notice, here's our starting weight, and here's the weight from our model, and the starting weight is about 1.5 grams less. Now this second part I'm not going to write down, so please write this down in your own words. So why do they differ? As you can see, we have the line best modeling our data in front of us, and that's exactly what it is. It is just our best estimate. The points do not necessarily lie directly on the line, but the line is as close as we can get to connecting all the dots. Let's use the regression equation to estimate when the soap will be gone. So if you recall, our regression equation is y equals negative 5.8779 x plus 125.5310 to 4 decimal places. Now, we want to know when the soap is gone. So that is when the soap weighs 0 grams. And these are the y values. So we're going to let y equal 0 and write negative 5.8779x plus 125.5310 equals 0. Now we can subtract 125.5310 from both sides to end up with negative 125.5310 equals negative 5.8779x. Finally, dividing both sides by the slope, which is negative, will give us a positive value for x. Namely, x is going to equal this ratio. And what is that approximately? We get 21.356 days. And I'm sticking to 4 decimal places as we have. And this is approximately. So a little over 21 days, about 21 1/3 days.